Salam sejahtera. My name is Gilta Davidson. So for today, we are from group number 3 are going to present our numerical project entitled Application of Numerical in Civil Engineering. So this is our team member, which led by Atla Alessandro, Gilbert Giltam, myself, Muhammad Aiman Daniel, Megat Muhammad, and last but not least, Nafis Anaki.
So for the topic that we want to discuss is the introduction, literature review, methodology, discussion, and also conclusion. The bisection method is used to find root of polynomial equation. It is especially useful for solving problems with a function represented as fx equal to 0. The approach is simple and based on the intermediate value theorem or IVT, which asserts that if continuous function of f change sign throughout an interval a and b, at least one root exists inside the interval. The answer is determined repeatedly by restricting the value after guessing, resulting in the correct solution. The resolve bisection method concern utilize the bisection method formula to calculate the value c of the function f(x) that crosses the x-axis. The integer c approximate that function f(x) root tolerate value at set for the bisection method program. Determine the value of c when the algorithm hits the actual root. So now we like to discuss about the problem statement and also the objective. So the problem statement that we find in the insufficient water tank in Block A Bumbung Biru at Taman University Parit Raja is because the issue is frequently run empty during emergency and also peak hours. They might not have enough water because of the size of the water tank. Given that Block A population is growing yearly, the size of the water might not matter when it comes gathering the necessary quantity of water. So the objective is to apply mathematical calculation with real application to calculate a cylindrical tank using the bisection rough method and the bisection method of the system nonlinear equation. To make a comparison between Newton-Raphson method and also the bisection method.
For literature review, the first one is water tanks. Water tanks are essential for holding water for various applications, including agriculture, drinking, irrigation, fighting fires, and more. They are available in variety of materials, each with unique benefits such as bladder tanks, plastic, steel, concrete, and fiberglass. They are flat-bottom, cylindrical containers with a variety of roof designs. Others have multiple rings spaced evenly apart, while still others have a stiffening ring to prevent localized buckling of the shell under wind pressure. The second literature review is minimum amount of water required per day. In developing countries, 20 to 30 liters of water per person is thought to be sufficient for daily needs. In these tables, there are level of allocation, use and amounts for liters per person per day. For minimum allocations, drinking requires 5 to 7 liters, food preparation and cleaning require 2 to 3 liters. For medium term allocations, this is sustainable for a few months. Drinking require 3 to 4 liters, food preparation and cleaning required 2 to 3 liters, personal hygiene 6 to 7 liters, and lastly laundry required 4 to 6 liters. For the third and last literature review is the filler table. In this table, we have facts, ideas, learning issues, and actions. The first fact is using the radius of 4 meters and 80 meter cubes. The idea is using the non-linear equations, and the learning issue is to apply the system of nonlinear equation into designing cylindrical tank. And the action we took is using the formula nonlinear equations. And the second fact is cylindrical tank to hold water. The idea is using the bisection method and Newton-Raphson method. The learning issue is to compare both method used, and the action is the formula bisection method and formula Newton-Raphson method.
Hello, my name is Atla Alessandro, and for today I'm going to present part I'm doing, which is the calculation of IVT, intermediate value theorem, and bisection method. So the formula that we use to calculate the IVT is V equal to pi r square H. So the V represent volume, R represent the radius of water tank, and H represent the height. First of all, we're going to arrange the formula, move the V to the right side, and it will become negative. We're doing this because we want to find the exact value. So after we arrange the formula, we will get 1.591549431 as the exact value. After that, we're doing the trial and error method to find is there one root in the interval. So we're going to substitute 1 into the hash, and by using calculator we get negative 39.7345, and we're trying to substitute 2 equal hash, then we get 20.5310. So there are negative and positive value under 1 and 2, so there is an interval root, so we can do bisection method. After we figure out there's a root in the interval 1 and 2, we're going to do a bisection method, which consists of I represent how many numbers of time you do the calculation, AI represent the interval root of 1, BI represent the interval root of 2, and CI is the interval between AI and BI. So next is FAI, which represent the value of AI, substitute into the formula, same as BI, and CI is same goes to CI. So we do the calculation. It consists of 15 times until we get the value of 0.0003, which is less than 0.0005. So since C15 is 0.00003, which is approximately 1.59155, which is the same number of our exact value. So that's all from me. Thank you.
So this is the continuous calculation from the previous method, which is bisection method. This method is called Newton-Raphson method. First of all, we can choose 1 because it is close to 1.59. So since C1i equal to 0.00003 that we get from the 15th iteration in bisection method is smaller than 0.0005, and approximately C1 equal to 1.59 meter.
So for the conclusion part, I'm going to present to you. In this project, we had a beneficial experience using numerical methods to solve engineering challenges through this project. To find the most accurate and efficient way to solve for liquid volume, we examine the outcomes of the Newton-Raphson method and the bisection method. Using several resources, the project also increased our knowledge of numerical methods and their technical applications. Working on this project also strengthened our teamwork abilities, emphasizing the value of cooperation in engineering and equipping us for upcoming problems in the workplace. That is all from Group 3. Thank you.